Okay, so I hope you had fun doing the distance formula yesterday, finding out about triangles, classifying them. Remember, we classified them by their sides, by their angles. We also used the triangle sum theorem and the exterior sum one. So, we're ready to move on. What we'd like to do in the rest of this chapter is prove that triangles are actually congruent. But before we do that, we need to understand an idea called correspondence. So that is the subject of today's lesson, the simple idea of correspondence, but a very important idea. So let's get going on it. So we're going to apply congruence, and we're going to deal with triangles. So our objective today, students will be able to identify congruent figures. And so what exactly do we mean when we say that figures are congruent? Alright, so we're going to read this together. Congruent figures. Two figures are congruent if they have exactly the same size and the same shape. Well, by the same size, we mean that they have congruent sides. And by the same shape, we mean they have the same angles. So, what it means here, the second point here, in two congruent figures, all the parts of one figure are congruent to the corresponding parts of the other figure. So, you might remember when we were dealing with parallel lines, we had what were called corresponding angles. Remember, we had a transversal. We have like angles 1, 2, 3, 4, 5, 6, 7, 8. And we said that there were corresponding angles. Like, for example, corresponding angles. Angle 2 and angle 6 are corresponding. Remember what it means to be corresponding? This angle 2 is on the top right side, right? This group of angles, the angle that's on the top right is angle 6. So corresponding, again, it's this idea of same position. Same position. And so that idea carries through on today's lesson. We need to make sure that we're looking at the sides of a triangle, sides, the angles, whatever, whether it's a triangle, quadrilateral, pentagon, whatever the geometric figure is, we want to make sure we match up the corresponding parts of those two figures. And so that's going to be the important idea in today's lesson. So let's see, make sure we do that. In congruent polygons, this means that the corresponding sides and the corresponding angles are congruent. And unfortunately, to say that things are congruent, we have to check all of them. Although we're going to learn later on in this chapter that there are actually some shortcuts. So for now, in today's lesson, to prove that things are congruent, we have to look at all the sides and all the angles and make sure they all are paired up and that they're all congruent. Alright, so just read, but copy the figure and corresponding stuff at the bottom of the page. Okay, so it says congruent statements. When you write a congruent statement for two polygons, always list the corresponding vertices in the same order. You can write the congruent statements in more than one way. Two possible congruent statements are as follows. So one of the things to realize that when we write a congruent statement, you see that symbol right there? As soon as we say two triangles are congruent, we need to make sure that everything matches up. A matches up with F. And so whatever you write first here must be first over here. And whatever is written second must come second. And third must be third. With the two triangles. Like for example, A, this angle here has one tick mark on it. and it matches up with angle F over here that has 1 tick mark. You see? Angle B has 2 tick marks, and it matches up with angle E. Okay? And then angle C is the third, matches up with angle D. So since A matches up with F, and they did this by doing the same color in both of these cases, this is what we mean by corresponding. The corresponding parts need to match up. You're not allowed to just put any of the 3 letters in whichever order. Once you have this statement written, these 3 have to be the ones that match up over here. Now, you have freedom to write the first 3 however you want. You can write the 3 letters here, whichever 3 letters you want. But as soon as you've written B, C, A, then you need to write over here the letters that match up or correspond with the first 3 here. So which letter does B correspond with? Well, as we said in the diagram, B matches up with E, and C matches up with D, and A matches up with F. Well, so that's the idea of corresponding. Now, the same idea happens with the sides. AB matches up with FE, okay? BC matches up with ED, and AC matches up with FD. So, that's a very important idea in this chapter, is that we write things in their corresponding positions, and everything needs to be matched up correctly. And it's easy to get this messed up, especially when diagrams are rotated. Like, for example, you might have a triangle like this, triangle like this. Alright, this side matches up with this side down here. This side here matches up with this side over here. And this third side matches up with this third side down here. You see? So it can be a little bit tricky based on your diagram. Okay, well anyhow, let's take a look at some stuff. So the first couple problems we're going to be doing is just writing correspondence statements. So identify all the pairs of corresponding parts. And so what we can say is that the corresponding parts, we could talk about the sides and the angles. So what we could say is that angle, for example, J matches up with what angle? Angle T. You see there's the 3 tick marks. So what we would say is that angle J is congruent to angle T. Alright? And we'll just separate these by commas. Angle K matches up with S. So we'd say angle K is congruent to angle S. We'll use another comma. And then finally angle L matches up with angle R. Alright, so identify all the pairs of congruent corresponding parts. Well, there's 3 corresponding angles, and now let's go ahead and do the sides. Okay, this side JK, okay, matches up with what? It matches up with this side over here. But how do we want to write it? JK is congruent to, now what I want to do is make sure that the letters match up also. J actually matches up with T, you see. So I want to call this segment TS, okay. Segment JK matches up with TS. Now, a lot of you might have written ST instead, and it's not entirely wrong, but really what you want to do in this chapter is making sure that this letter matches up with this one matches up with this one. And this idea of correspondence, that's what you're expected to do. Especially when you have two triangles involved. So that's how I want you to do this assignment as well. Okay, so the next segment I'm going to talk about is this one, KL. KL matches up with which segment? So congruent symbol. The K matches up with the S, so I want to put S here, and then the L matches up with the R. So in this diagram we're talking about that segment, and we're going to call it SR. Okay, so again, what I want you to do and be in the habit of doing is making sure that these match up, the corresponding parts match up anytime you write a congruent statement. Okay, that's what I want you to do. Okay, so we have the final leg here, the final segment of this triangle. What we would say is that we could call it JR, or excuse me, JL. JL is congruent to which one? Well, the J matches up with what? Well, it matches up with the T. And so this side is going up this way. So it matches up with T, and then it goes clear up to R. Clear up to R. So the segment that corresponds to JL is TR. Okay, so those are the 6 parts that are congruent, and they're all the pairs of angles, pair of sides. So you'll be doing that on your assignment as well. Just practice. Alright, so here's another problem we can try, and you can we just did it. And so maybe a couple students could practice this. For the Camtasia video, we're going to go ahead and skip this. It's the same exact thing we did on the previous problem. What I will do, instead of writing them all out, I'll just mention them real quick. This side XY matches up with this side here. XZ matches up with NP because it has the 3 tick marks, and this one has the 3 tick marks. And then finally, YZ matches up with MP. Okay? And then we have the angles that match up also. This angle matches up with this angle. So angle X is going to be congruent to N. Angle Y is going to be congruent to M. And angle Z is going to be congruent to angle P. Okay, don't make that too complicated. Just make sure the letters match up when you write the statements. They need to match up in the corresponding parts. Okay, so now I want to point out something very important. Anytime you write a congruent statement, you need to make sure you write it correctly. The letters need to match up. D matches up with S. And take a look here. Here's D. D matches up with S over here. That's this spot here. Okay? And so for example, since we know that angle D is 102 degrees, we could also say that angle S is 102 degrees. Because we were told this congruent statement here. So all the parts, all the angles of this quadrilateral are going to be congruent to all the angles over here as well. Like for example, G matches up with what? You can see what G matches up with because of the congruent statement. This says it matches up with R. Okay, so that means angle R is 84 degrees. You see, 84 degrees. Okay, so hopefully you get the idea. The congruent statement, when you write it, it's very important that all the angles, all the letters match up and they're all in the correct position here. Well, now let's go ahead and move on to our problem that we're after. We're after the value of x. Okay. Well, so I see the value of x right here. So what I could do is I could use this side here, and I say it's congruent to which side? Well, this is QR, right? Well, QR is these two letters. So this segment here has to match up with the two letters that are last over here. Has to match up with FG. Well, FG is down here. So what it means is that this segment here is congruent to this segment here. Those two are congruent. And if they're congruent, then I can get an equation. It looks like to me 2x minus 4 must then be equal to 12. Well, this is almost too easy to solve. Move the 4 across, so we get 2x is equal to what? You're going to add 4, right? Add 4 here, so you can get 16. And then divide by 2, and you get x is equal to 8. Okay? Too easy, right? We can also solve for y. Now that we have x figured out, we can substitute x in for right here. We can put the x in right there. That's going to be an 8. But what we want to do is find out q here. Q matches up with which angle over here? There's 4 angles. And looking back at our correspondence, our congruent statement, we know that q must match up with angle F. You see? It's in the 3rd spot, so that's also in the 3rd spot. So here's angle F right there. So these two angles must be congruent. And so that gives us our other equation. We're going to say 68 degrees is equal to, must be equal to this one over here, 6y plus x. But we just found out that x is actually equal to 8, so we're going to put an 8 right there. And now we're going to solve for y. I'm going to subtract 8 here, subtract 8 here, and this gives me 60 is equal to 6y. How easy is this? I mean, divide by 6 over here. Okay, and we get y is equal to 10, right? So the main thing here is that the algebra is not too hard. That's the first thing. But the point is, you have to make sure that when you're solving for x, you get the right equations in here. You make sure the parts match up. And so that's the only difficulty here. Maybe you should try this now. It's not so hard when the figures are matching up. I mean, they're kind of, when this diagram is rotated a little bit and this one's not rotated, for example, it can be a lot more challenging, but it's pretty easy. I mean, this one matches up. This is on the left side, that's on the left side, this is on the bottom, that's on the bottom. Everything matches up really nicely between these two. So when we get our equations, if we wanted to find x, for example, this side here matches up with this side. Okay, so those are the corresponding positions. And you can tell that is the case because AB matches up with FG. Okay, so AB here matches up with FG here. So that gives us our first equation. 9 must be equal to 3x minus 6. So we're going to move the 6 across by adding 6. And that's using that property of equality, right? This is the addition property of equality that we learned a long time ago. So we get 15 is equal to 3x. And we can divide by 3 on both sides of an equal sign. So we get x is equal to 5. Okay, well, now that you got x figured out, notice we needed to find x first before we could solve for y. because we could substitute in for there. And so let's work this out. FK, this angle right here is angle K, right? Angle K matches up with angle D. So let's find out D. D is right here, so that's this angle right here. And we know the measure of that angle is 44. So what we can say is that this angle and this angle must be identical or equal. So that gives us another equation. 44 must equal 4x plus 2y. But we just found out that x is actually equal to 5. So if that's a 5, that makes this 20, okay, plus 2y equal to 44. Just erase a little bit now. And so now we could subtract 20 on both sides of an equal sign. And that gives us 24 is equal to 2, that's a y, not 24. And then divide by 2 and divide by 2 here. And I get y is equal to 12. How about that? So we were able to solve for x and y. And so the key again is just to make sure all the sides and angles match up. Well, now this theorem is pretty simple. It says, look, if you know the first two angles are congruent, then the third angle automatically is congruent. Think about it. We'll just use numbers real quick. If, for example, if this angle here is 110, well, that means this one's 110, right? And let's just say this angle is 30. That means this one's 30, right? You know that they all have to add up to be 180 total, right, for any triangle. So that already adds up to 140, so that means the remaining angle is 40 here. Well, that means same thing is true over here. The remaining angle must be 40. So all this theorem is saying, hey, if you know two angles of a triangle are congruent to two angles of another triangle, then by goodness, the third angle automatically is congruent. Really? Alright, well, that's pretty simple. So, oh my goodness, so here's where diagrams start getting tricky. So, find the measure of BDC. So, here's where it gets a little bit tricky. We have this angle here is 45 degrees and there's a congruent mark. So it's 45 degrees over here. This angle here has 30-degree mark, or it has 2 tick marks. This one has 2 tick marks, so that was 30 degrees. Now where is BDC? BDC is this angle right here. Okay. There's BDC. So we're trying to figure out what that angle is. Well, this gets complicated because there's multiple triangles in here. I mean, you have this triangle right here, and it matches up with this triangle over here, like these two triangles. And then you have this triangle sitting on the bottom. But there's two other triangles that do sort of match up here, and I kind of like to outline them a little bit. Here's a triangle here, this big triangle, and it goes over here. Alright. Alright. You see that big one? Now it matches up with this other triangle that's big on the right side. And it matches up over here. You see? Alright, well, so for any triangle, the three angles have to add up to be 180. And see, so if we consider just the yellow triangle for a second, we can find out this angle right here, because we know two of the angles already. And we know that they have to add up to be 180. So let's just add those two together. I get 75. Now let's just subtract, and we can find out this angle right here, this big angle right here. And so that looks like to me it's going to be 105 degrees. Okay, that's this angle right here. But that being said, if you look at this triangle on the right side, the one that I just drew, I'll redraw it here in blue. Okay, we have the two angles that we know already, and that matched up with these two angles over here, 30 and the 45, the 30 and the 45. And so this angle here actually is a corresponding angle to that one. So this angle here is congruent to this one over here. So that means then that the measure of angle BDC is equal to 105 degrees. And we're done. So this one is a little bit trickier because the triangles kind of overlapped each other. And so anyhow, this side right here matches up with this side over here. This big long side here matched up with this long side over here. This short side here matched up with itself. And that's the other thing that can be confusing. Certain sides can be shared by two different triangles. They'll match up with themselves. So we're up to our central question. Oh, let me back up. Sorry, I went fast there. What are congruent figures? Congruent figures are figures that have exactly the same size and shape. So we're practicing the idea of corresponding parts, corresponding angles, and that sort of thing. Also make sure that when you write the correspondence statements, like if you want to say triangle ABC is congruent to triangle over here, you better make sure that this one matches up with the first one on that one, the second one matches up with the second one on that one, and the third one matches up with the third one here. That's a very important thing I want you to do, and we're going to be using that idea the rest of this chapter. So there you have it. We are like done.